This is the last part of the final exam practice. So this is chapters 11 and 12. Oop, hit button. Okay, so chapter 11 is, it's so small. Chapter 11 is irrational fractions with a lot of factoring. We're multiplying, dividing, adding, subtracting, all that noise. So when you were multiplying, the first thing you do is factor everything you can. So if you factor out this numerator, we have x times x minus 2. And again, I strongly recommend, just like I said in class, I would do it. I know some people here, and then do this one down here, and it gets pretty big. If you did it that way and you did fine on the chapter 11 test, then that's completely up to you. But if you struggle with that, I would definitely recommend doing some space like I'm doing. So factors of negative 18 add up to be 7 are x minus 2, negative 18, and 3 positive 7. Good. The next one is a difference in squares, so that's x plus 9 and x minus 9. A lot of people had x plus 81, x minus 81 on their test when they took it. That looks a little bit different. Factors of 18 add up to be negative 11 are x minus 9 and x minus 2. Again, those multiplied by positive 18 add up to be negative 11. So if multiplication, that's really the biggest thing, because now, if you have the same thing in the numerator and denominator, they cancel, even if they're in different ones. So for instance, this x plus 9 and this x plus 9, even though they're in different fractions, that doesn't matter, they still cancel. So this x minus 2 can cancel either this one or this one, doesn't matter which one. X minus 9, x minus 9. So now if you look back, everything canceled in the numerator except for this x, so what we have left is x, and the denominator, everything besides the x minus 2. So that's your answer for that one. Now 41, a division problem is literally identical to this. The only difference is we have to make it multiplication first. Now again, I would recommend writing out like normal without factoring. Make a multiplication and multiply by reciprocal. If you want to factor while you do that step, that is up to you. I don't recommend it, but some of you guys are pretty good at that. Again, you already took the test over this, so you should know kind of your strengths and weaknesses on this. Once you have multiplication, now it's exactly like the one we just did. So factors of 4 that add up to negative 5 are negative 1 and negative 4. This is the difference in squares. So this is x plus 1 and x minus 1. Now again, you might say, well, but Mr. Stefan, the 1 is right there. So why is it 1? Because remember, the square root of 1 is 1. So that is, or 1 squared is 1, depending on how you want to look at it. That's why we got 1 here. Over here, we have 9s, because the square root of 81 was 9. Factors of 4 that add up to be 5 are x plus 1 and x plus 4. And the next one's difference in squares, x plus 3, x minus 3. That colored actually doesn't look too different than the blue one, but that's okay. So again, now we have this set up, just like the multiplication, now we can cancel out numerator denominator. So x minus 1, x minus 1, x plus 1, x plus 1. That looks like everything that cancels. So you're left with, in the numerator, x plus 4 times x, x minus 4 times x plus 4. Doesn't actually matter the order, but over x plus 3, x minus 3. Now, if you wanted to multiply those out, you totally could. So you'd have like x squared minus 16 in the numerator, x squared minus 9 in the denominator. That'd be great. This is what it will look like on your multiple choice. I don't want to make you do more work than you need to. I probably should, but I'm not going to. I did not do that during the test. I'm certainly not doing it during the final. So adding and subtracting, remember the difference with this one is you've got to get common denominators. So you do these differently than the other multiplying and dividing. So your common denominator, or I guess I should say, you start by factoring. So x squared minus 9 is x plus 3, x minus 3. The other one's x minus 3. So we need those denominators to be the same. So they both have an x minus 3, that's great. And they both need an x plus 3 then, since that one has it. So I multiply top and bottom by x plus 3. My numerator is 2x, and my denominator is x plus 3, x plus 3. This one, when you distribute, I get 2x squared plus 6x over x plus 3, x minus 3. Again, the denominator should be the same. Doesn't matter which order you recommend. So your final answer, your denominator, is that common denominator, x plus 3, x minus 3. Your numerator now, you just combine like terms. So the 2x squared doesn't combine by anything. 2x plus 6x is 8x. So that then is your answer. Let's clear up a little space. Oops, sorry. Clean up some of that. Another one with plus, so you do this the same. We have x. You can always factor out a greatest common factor. A lot of people with this one, the one that was like this on the test, just forgot to take out a 2. So they left it at 2x plus 4, so they multiplied this one by 2x plus 4. It was a nightmare. Technically, you can do it that way. You just have to reduce your fraction at the end, which is not ideal. So take out a 2. What's happening? All right. Hope you're still good. Let's check this. Yep. Okay. 2 plus, we have 2 over, and then we have x and x plus 2. So again, same thing. You can take out an x, which leaves you with x plus 2. So now when you look at these, again, they have to match. My computer's going slow now. We have the x plus 2 and x plus 2 in both of those. So those already match. So this one on the right needs to have a 2 to match this 2. And again, top and bottom. This one on the left has an x, so this one needs an x, top and bottom. So what you're left with is, in the numerator, x times x is x squared, and my denominator is 2 times x plus 2. That's that common denominator. Plus 2 times 2 is 4 over, got to be the same thing, 2x times x plus 2. Now that your denominators are the same, that is going to be the denominator for your answer, 2x and x plus 2. Sorry, my writing is lagging behind a little bit. Your numerators combine like terms. There are no like terms, so it stays x squared plus 4. But you've got to get common denominator before you combine those. Now, subtraction is literally the exact same thing as plus. The only difference is what I always do is I change that minus to a plus, and I change the numerator after that. I put a negative in front of it. If it was a binomial, so if you had like blah, 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 subtracted by x plus 4 over blah, blah, blah. If you do that, you change it to a plus, and both of these change to their opposites. You distribute the negative to both of them. That's a big mistake that a lot of people make. Oh, no. Okay. So once you do that, now it's literally the same thing as the ones we just did. So we have factors of negative 12 that add up to be 4 are x minus 6, x plus 2. That multiplies to be negative 12, adds up to be negative 4. It is worth double checking that, in my opinion. The next one I can take out a 4, which leaves x plus 2.
Just want to show off the spread.
Sorry about that. So we need the denominators to be the same, just like usual. So again, we have the x plus 2 and x plus 2, so that's great. So this one has a 4, and this one doesn't on the left. So we need to multiply top and bottom by 4. The one on the right doesn't have an x minus 6, so we need an x minus 6. So now they all have a 4, an x minus 6, and an x plus 2. So that is our common denominator. Doesn't matter which order you put them in. I'm going to go ahead and write that out since I'm already doing it. My numerator is then 12x. My numerator over here is negative x plus 6. Again, don't forget that negative 1 distributes those. So now your denominator is 4 times x minus 6 times x plus 2. Again, if you want to multiply that out, you can. My numerator, then you just combine your like terms. So 12x minus x is 11x, and then plus 6 is the only thing. There's nothing that combines with that. So that is your answer for that one. Okay. Sorry, my wife texted me and said RSVP'd for tacos, so that deserves a little bit of a break. Have to double check the important things. Okay, so the next thing we're doing is solving. Now, again, for solving, it's literally the same thing as adding and subtracting, where you try to get the same denominators for everything. So again, I'm going to rewrite this with my factor denominator. That's going to be x minus 3, x minus 1. Again, double check, that multiplies to be positive 3, adds up to be negative 4. That's important. And 2x and x minus 1. Yes. X over x minus 3. I left myself some space because I know what's coming with this. It kind of depends on, you guys can do that if you remember. Now we need all the denominators to be the same. So this one has an x minus 3, this one has an x minus 3, and this one doesn't, so I need to put it in there. So multiply top and bottom by x minus 3. So now they all have an x minus 3. Now they need an x minus 1, so these two have it, and this one doesn't, so I need to multiply top and bottom by x minus 1. I know this sounds redundant and repetitive, but now my denominators are x minus 3, x minus 1. X minus 3, x minus 1 is equal to x minus 3, x minus 1. Sure, we get 8x plus 5 out of it. So we distribute, so we have 2x squared minus 6. What happened there? 2x squared minus 2x. Here, I'm going to, okay. Other denominators. So don't actually do this on your paper. It's multiple choice, so it can't be one. We're just looking at your numerators. So like 8x plus 5 plus 2x squared minus 6x is equal to 2x squared minus 2x. To combine your like terms, that's the first thing I would do. 2x squared, x minus 2x, and plus 5. This side we have 2x squared minus 2x. So actually I'm going to give myself a little bit more space, let me rewrite that up here. 2x squared plus 2x plus 5 is equal to 2x squared minus 2x. So that's going to go up here quick, just because I ran out of space. Now from here, I know it looks confusing because they're quadratics, and technically you could solve a quadratic either by factoring or the quadratic formula, but you don't actually have to, because the first thing I do is I subtract 2x squared from both sides. So it cancels over here. But if 2x squared minus 2x squared cancels on the left, it's also got to cancel on the right. So we actually don't have any quadratic because the x squares canceled. Now the x's are, whoops, actually I'm going to do that differently. You could have done where you added the 2x. You just have to remember there's a 0 on the right. So instead, I'm going to subtract the 2x from both sides. So that's 5 is equal to negative 4x. Divide both sides by negative 4. That is fine as your answer. Remember, 5 over negative 4 is the same thing as negative 5 over 4, which is the same thing as negative 5 over 4. Just in case you need that, I don't know how the answer is going to look, or if it's going to be like this on the final. If it is on the final, I don't know how the answer is going to look. Okay, so let's erase a bunch of this. Should probably pause and save some time, but that's okay. Sorry. Okay, so what are the excluded values? So this one's not too bad. Remember, that just is what makes the denominator 0. So on my answer key, I actually factored out the numerator and the denominator. You don't really have to factor out the numerator. The excluded values are just what makes the denominator 0. So that is x plus 4, x plus 5. Now, the reason they do this is to trick you. I don't remember if the one on the final exam is like this. But yes, if you were to simplify this, those would cancel, but it doesn't matter. Even if it cancels, that's an excluded value. So don't forget that. I don't remember if it's on the final exam like that or not. But the answer for this one, the excluded values, x cannot be equal to -4 or -5. I know -5 cancels, but that doesn't matter. It's still, even if it cancels, it's an excluded value. Because again, what makes the original denominator 0 before everything cancels. And speaking of, that kind of brings us into the next one. What are any vertical asymptotes, x-intercept, and holes? Now again, the vertical asymptotes is what makes the denominator 0. The x-intercept is what makes the numerator equal to 0. And the holes are what canceled. So if anything cancels, that's spelled wrong, but that's okay. That's going to be a hole. There could be more than one of those. There could not be one of those. So if there's not an asymptote, you just put an A. If there's 2 intercepts, you just list both of them. That's all possibilities. So just like when we simplify, we're going to go ahead and factor. So we take out 3x. That leaves x minus 2. Factor to add up to be 2 are x. X minus 2 multiplied to be -8. Add up to be 2. Again, it definitely is worth double checking that. So the x minus 2 cancel, so we end up with 3x over x plus 4. Now, first thing, since the x minus 2 is canceled, that is your whole. Remember, it's what makes that equal to 0. So since we canceled x minus 2, you'd add 2 to both sides, you get x is equal to 2. A lot of people just remember it as the opposite sign. If you want to do that, that's probably okay, but that's a whole. X is equal to 2. For vertical asymptote, what makes the denominator, what makes the denominator equal to 0? So again, you can either solve it and subtract 4, or just it's the opposite of that. So x is equal to -4. And the x-intercept will make the numerator equal to 0. A lot of people want -3, but remember, 3x, if you make that equal to 0, if you solve that, divide both sides by 3, your x-intercept is just 0. So let's go ahead and do next one. All right, sorry about that. So this next one, same thing. The numerator is already factored out as much as you can. Factors of 4, -4 that add up to be 3. That would be x plus 4, x minus 1. Those multiply to be -4, add up to be 3. So we're good there. Nothing cancels on this. So since nothing cancels, your holes are none. You don't have any holes because holes only happen when things cancel. So my vertical asymptote is what makes the denominator 0. So we're going to have 2 of them. X is equal to -4 and +1. That's fine. You can have 2. And your x-intercepts are what make the numerator 0, which would be +7. Oh man, I thought I was almost done. On to chapter 12. Hopefully I have time to finish. Okay, the chapter 12 stuff should go fairly quickly because there's a lot less to it. A lot less factoring and all that noise. So I rolled a number cube 14 times. A number cube is a dice. Cubes have 6 sides, so there's 6. It landed on 4 8 times. Find the experimental and the theoretical probability that you will roll a 4 for the next roll. So experimental is when you actually look at the experiment. So you roll 14 times, and you got a 4 8 times, so 8 out of 14. When you reduce that down, that is 4 over 7. Or you could find the percentage, it's 0.57 or 57%. Doesn't make any difference. All those answers are fine. I forget how it is on the final exam, which one they actually use. So I guess it is multiple choice. So make sure if you find 4 over 7, make sure you can also find the decimal and the fraction. Theoretical probabilities, we forget about this whole experiment and we actually just look at what we're given. We make a theory without rolling it. We make a theory what's going to happen. There are 6 sides on the dice. One of those is a 4, so 1 out of 6, which is 0.17 or 17%. Given the following data. So again, count like 1, 2, 3. I guess I don't need to be zoomed out so much anymore. 4, 5, 6, 7, 8, 9, 10. So there's 10 data points. We want to know what the 40th percentile is, so that's 0.40. When you multiply that together, that's 4. So the fourth number, the is what we're looking for. 4 is not your answer, the fourth number. So that is 58. I roll a standard number cube, and then I spin a spinner. What is the probability that I roll an even number and, which is important, a multiple of 3? So, and, this is the formula sheet you'll get on the final exam. And is right here. Sorry. So that means you multiply of my A. I guess I should make it a little bit more specific. The probability of the first thing, what's the probability I roll an even? There are 3 evens out of the 6 total. What's the probability I spin a multiple of 3? Well, multiples of 3, I've got 3, 6, and 9 are all multiples of 3 between 1 and 10. So that is 3 out of 10. So all you need to do then is multiply those together. 3 over 6 multiplied by 3 over 10. Again, since it says the word and, you multiply. So that's 9 over 60, which again, obviously, once you reduce that down, that's 3 over 20. Or that's 0.15 or 15%. Again, I don't care which one you do. Just make sure you know how to find each one of them. I don't know how it is on the final exam. I forgot. Next one, 9 people are running a race. How many ways can they finish first, second, third, fourth? So we are ranking them. If you're ranking them, the order matters, so it's a permutation. If you're confused about this still, you can double check back in chapter 12. If you look at the permutation combination lesson, I think that was 12.3, 12.2 or 12.3. I don't remember which one. But I had a list on how to tell a difference between permutation and combination. So there's 9, permutation 4. If you want to know the formula, it is right here. But again, it's multiple choice, so you don't actually have to have the formula. But if that's the way you did it, that is 9 factorial over 9 minus 4 factorial, which is 9 factorial over 5 factorial. Now, even if you do it this way, personally, if I were you on the final, I would not do this at all. I would just put that in my calculator. You can do it either way, but I do know there's some people on the test, not a lot, that had the right work here, and then they didn't have the right answer. So I think it's the safest to put that in your calculator. But 9 permutation 4 is 3,024. Now, since the order does matter, the other way to do this one is to say we have first, second, third, and fourth place. 9 runners can be first, which leaves 8 for second, which leaves 7 for third, which leaves 6 for fourth. If you multiply that out, it's the same answer. That works because the order matters. It's a permutation. For 53, you can't do it that way because the order doesn't matter. So let's look at 53. 10 people on the team run the race. My coach has to pick 4 out of the 10 to compete in the next meet. The order doesn't matter because he's just picking 4 to compete. There's no first, second, third, fourth. There's no president, secretary, vice president, none of that. It's just picking 4 people. So 10, combination 4. Again, if you want to show your work, ten factorial over 4 factorial times 6 factorial. I would just put that in my calculator if I were you. If you are planning on doing that, I would make sure you know how to put it in your calculator. That's definitely a thing. So if you put that in your calculator, you end up with 210. Now again, if you took 10 times 9 times 8 times 7, it would be a permutation where the order matters. And this one, again, the order doesn't make any difference. Polls, it's regular $85. It's on sale for 14% off. How much will the jacket cost with the sale? So how much is the jacket going to cost? Now remember, there's 2 ways to do this. I honestly think the easiest way is if it's 100% normally, we're saving 14%. So how much are we paying for? What percentage? Well, 100 minus 14 is 86. So we're only paying for 86% of the jacket. So $85, I'm paying for 86% of it. So multiply that by 0.86. That gives you 73. To do this, if you want to, is you could have taken 85 multiplied by 0.4. That's going to give you 11.90. So that's how much money you save. That is not the answer. You do not buy this jacket for $11 when it originally costed $80. That's definitely not 14% off. That's well over 50% off. So to find your answer, then you take your original 85 and subtract 11.90. That gives you that same 73. pair of shoes I really like. I wasn't going to buy them, but they were on sale. Worthless information. The original cost of the shoes were $90. They're on sale for $72. How much percent off are they? Now again, there's two different ways to do this. They were $72. Originally 90, so you can do this math. 72 divided by 90 is 0.8. But again, that doesn't mean the sale is 80% off. That means you paid for 80% of the shoes. So how much percent off were they? 100. Sorry, I should do the other way. 100% minus 80, so they were 20% off. But the other way to do it is, again, you could say, well, if I spent $72, I wanted to find out what the percent off was. 72 is not how much money off. That's how much money it cost. We want to find how much money is off. So if it is $72 that we paid, that means it is $18 off. We're saving $18 on that. So if it's $18 off, to find what percentage off, you divide that. That gives you that 0.2, which is 20% off. Either one of those is fine. So that brings us to the end. Obviously, if you have any other questions, make sure you let me know. Other than that, good luck on the final. Hopefully it treats you well.